Hey everyone, in this video I'll be covering polynomial operations. So that is addition, subtraction, and division. We do have another video for multiplication because that should probably be treated as its own topic. So let's get started. Alright, so first we need to address, just as a review, what is a polynomial? So what we define as a polynomial is, obviously it's a function, so let's write p for polynomial, like p of x. And then, so the main characteristic of a polynomial is that it is going to have, obviously, it can have, any kind of, so we can split it into two things, which we can call the coefficient of each term, where we are defining the term to be something which has the variable in it. So I think it'll be clear if I write it out. So let's do like x cubed plus 2x squared plus 5x minus 6. So this is a polynomial, and it highlights some of the things that qualify a function to be a polynomial. So the first thing is that every power of x, or the variable, has a non-negative integer power. So what this means is natural numbers, so stuff like 0, 1, 2, 3, and so on and so forth. So if we had something like, let's say f of x equals x to the 3 halves, this is not a polynomial. And similarly, f of x equals x to the negative 1, which is just 1 over x, is also not a polynomial, because it has, in the case of this one right here, it has a fractional exponent, and in the case of this one, it has a negative exponent. So these two functions are not polynomials. So the actual coefficient of the term doesn't really matter. It can be whatever number we want. And these don't have to be integers. So the only condition that we really need to stress is that you have a non-negative power of the variable in every term. Notice I put x to the 0 in red parentheses here. I did that because in my definition, I said non-negative powers of the variable, so x. For our cases, it will always be x, but you may see like t or something else, depending on the context. So non-negative means any number that's not negative, so that includes 0. And if you recall, any number, regardless of its value, to the 0 power is just 1. So here, we're really writing 6 or negative 6 times 1, or x to the 0. So there's still a power of x there. It's just 0. And that's why we can have what we call constant terms in our polynomial. So you should probably already know this definition, but if it was a little hazy or you didn't know it before, well, now you know. So let's move on to addition. So just like with normal numbers, we can perform the standard for arithmetic operations on polynomials as well. That would be addition, subtraction, multiplication, and division. So we're not covering multiplication in this video. It has its own separate video because it's arguably a bigger topic. But for addition and subtraction, at least, I wrote additional, sorry. For addition and subtraction, at least, it's very similar to, normal addition and subtraction. So really what we need to do is introduce a concept called like terms. So like terms means if we have two different polynomials, so let's say p1 of x is going to equal like x squared plus 2x plus 1, a very familiar and nice polynomial. And then let's say p2 of x is going to be like x cubed plus 5x minus 6 or something. making these up as we go because it really doesn't matter. So, like terms means, let's consider 1. So the like term for 1 in p of 2 would be -6 because they share the same exponent in the variable, which would be x to the 0. So we call that the degree of the term. So basically, when we say like terms, we want to pair every term in one polynomial with the term in the polynomial that we want to like add or subtract or divide that shares the same degree of x or the variable. So for 1 it would be -6. For 2x it would be 5x. Now something important here, for x squared we don't have an x squared term in P2, but we can add one in the sense that we can tap into here and we can put 0x squared. And for our intents and purposes, we'll treat it as though there is a 0x squared term. Now, obviously, 0 times any number is 0. But we can make these two like terms, and we can, when we're adding, we just do, in this case, 1 plus 0. And for x cubed, it's the same case. We don't have an x cubed term here in P1, but we can just do 0x cubed. So, to add two polynomials, all we have to do is add the like terms. And we get our answer. So our answer, let's call that P3, just to keep with our little naming convention here. So let's go by highest degree to lowest degree, because that's usually how we write these things. From left to right, we'll write the highest degree terms first. So from P1, we have 0x cubed, and in P2, we have x cubed. So 0x cubed plus x cubed is like the same thing as 0 plus 1. It's just x cubed. Okay, so same thing here. X squared plus 0x squared is going to be x squared. For 2x plus 5x, it's just 7x. And for 1 plus -6, it's -5. And that is addition. Pretty simple, right? It's basically just the same thing as adding two normal numbers. So let's go on to subtraction. And in this case, let's use the same two polynomials from before. And I believe it was x cubed plus 5x minus 6. Okay, so let's compute P2 of x minus P1 of x. So subtraction. So for this, we do the exact same thing, except instead of adding the like terms, we subtract them. So I've chosen P2 of x minus P1 of x for a reason. The degree, or the value of the highest power in P2 of x, is greater than the degree for P1 of x. 3 is bigger than 2. And this way we'll get a positive answer, which I think is just less writing. So we are going to consider all our like terms again. So we have x cubed in P2, and we have a 0x cubed in P1, because there isn't actually an x cubed term in this polynomial, but we put it there anyway, just so that we can kind of conceptualize our subtraction. So we just have x cubed. Now, we don't have an x squared term in P2, but we have a 0x squared. So this is why it's important, because now we have 0 minus x squared, or 0x squared minus x squared. And this is going to be -1 times x squared. So we have minus x squared here. Then 5x minus 2x is 3x. And -6 minus 1 is -7. So we have our answer, which is going to be x cubed minus x squared plus 3x minus 7. So that is subtraction. So addition and subtraction are pretty much the same thing as adding and subtracting regular numbers, except we pair them by like terms. So in the end, it's basically the same thing, in my opinion. So let's move on to division. I'm going to say one more time that multiplication is in another video. But here I'll give you two examples. So division for polynomials is, again, like addition and subtraction. It is really similar to the standard integer or the standard long division that you've learned before. So let's consider, let's say, let's do x cubed plus 3x squared plus 3x plus 1 divided by x plus 1. So, just like normal long division, we're going to look for a value that we can multiply x plus 1 by so that we get sort of as close to x cubed plus 3x plus x cubed plus 3x squared plus 3x plus 1 as possible. So this is x squared. Because if we multiply x plus 1 by x squared, we're going to get x cubed plus x squared. And we can then subtract this minus x cubed plus 2, x squared. And we're going to get 0 here plus 2x squared. And then we can bring down the 3x here plus 1. So now we can do the same thing. So for x plus 1 and 2x squared plus 3x, we're going to multiply by 2x. So that gives us, and here we get 2x squared and minus 2x. So when we subtract this out, we get x, we bring the 1 down, x plus 1, x plus 1 here, and you'll notice x plus 1 and x plus 1, all we need to do is just multiply by 1, so we add a 1 here. And there we go. So it's pretty similar to integer division. And you may remember that the remainder exists when you're dividing normal numbers. So you might think, is there a remainder when I divide polynomials as well? And you would be correct. So I will now show you an example of a problem with remainders. Just a quick note here, you might have noticed that if we factor this, it's actually x plus 1 cubed. If you factor the answer, it's x plus 1 squared. And we were dividing x plus 1 cubed by x plus 1, and we got x plus 1 squared. Just a quick note. So let's look at an example with a remainder. So we're going to be dividing x cubed plus 5x squared plus 3x plus 4 by x squared plus 1. So like we started before, we're going to pick a value that we can multiply x squared plus 1 by to get us close to x cubed. So that would be x. No, that doesn't look like an x. Here we go. Okay, so x. So we're going to get x cubed plus x. And now, remember what happens when we don't have an x squared term while subtracting. So since we're subtracting these two polynomials, we're going to pretend as though we have a 0x squared here. So what we can do is we get 0 plus 5x squared, because we're subtracting a 0, plus 2x. And all we have to do is we'll add a 5 now, because now we'll get 5x squared plus 5. And then if we subtract this, we're going to get 2x minus 5. But we bring down the 4. And we're going to get 2x minus 1. Now, if you notice, there's nothing we can multiply x squared plus 1 by. There's no polynomial we can multiply x squared plus 1 by to get 2x minus 1. If we were to do that, we would get, obviously, a fraction with polynomials in the numerator and denominator, but that's not actually a polynomial anymore. So we stop here, and we say that the remainder is 2x minus 1. So our answer is going to be x plus 5 with the remainder of 2x minus 1. And that is all. That's everything you need to know about polynomial operations aside from multiplication. As you might have seen, it's a lot like doing the same things with actual numbers. You just have to pair the like terms. Hope you learned a lot, and I'll see you in another video.